Question 1 is on kinematics and really test your understanding of a speed time graph. So in this question, the car accelerates from rest to 30 meters per second in 5 seconds. Then it travels at 30 meters per second for 30 seconds before coming to rest at a uniform deceleration of 2.0 meters per second square. So plot a speed time graph of the car. So the car starts from rest to 30 meters per second in 5 seconds. So we'll start off with time 0, then to 5 seconds later at the speed of 30 meters per second, and we will assume constant acceleration or uniform acceleration here. Then it goes on to 30 meters per second for 30 seconds. So we will assume it goes at constant speed. So 30 seconds here, and it moves at constant speed. Next, it decelerates to rest to 0 meters per second at a uniform deceleration of 2 meters per second squared. So to find the time, you need to use your kinematics equation, which is v equals to u plus at. And in this case, the final speed is 0 because it comes to rest. Its initial speed is 30. Its acceleration is minus 2. And from there, we can find time is 15. So time with 15 seconds. And because this is uniform deceleration, it will be a straight line graph. And this will be your speed time graph. Continuing with question 1, part B, calculate the acceleration of the car as it increases its speed from rest to 30 meters per second. So we are concerned about the first part of the speed time graph from 0 to 5 seconds. And using the kinematics equation, A equals to V minus U over T. The final speed is 30 minus the initial speed of 0 divided by the time taken will give us 6.0 meters per second square. Now, it is important that you give your answer to the correct SF and correct units. So in this case, it is to 6.0 meters per second square. Part C, calculate the total distance moved by the car. Here you need to state, and I strongly recommend you to state the physics concept related to this. The total distance is equal to the area under the speed time graph. And from here you can calculate the area of the trapezium, or you can calculate the individual areas of the triangle, rectangle, and the triangle and add them up. In part D, at time 20 seconds, the car has a driving force of 9,000 Newton. Explain why the car travels at a constant speed even though the car has a driving force. So here we're concerned about the point where it moves at constant speed. And using Newton's first law of motion, now you do not need to state Newton's first law. You just need to know how to use Newton's first law. The forces on the car are balanced, which means resultant force is 0. Now, it is not enough for you to just state this. You must explain why are the forces balanced. And the magnitude of the frictional force is equal to the magnitude of the driving force. And thus, the resultant force equals to 0. And therefore, acceleration is 0. Therefore, the car moves at constant speed. The last part, part E, calculate the force needed to provide the deceleration. So in this section here, we are just really looking for the resultant force to give this deceleration. And so F equals to MA, and that will give you 3,000 newtons. Question 2 is on a question on vector addition. So here we have a stone that is supported by 2 strings, and the tension on the strings are 1.3 newtons and 2.0 newtons. You are supposed to draw a scaled diagram to determine the resultant force of these two strings. So the very first thing that you need to do is to come up with a scale. Now, based on the space available in your diagram or in your question paper, and plan out a scale such that you can get a reasonably large diagram. The larger your diagram, the more accurate you are. So in this question, we can use a scale of 1 cm to 0.2 newtons. Now, the way you state your scale is always based on the length to the force. So the first thing that we draw is the horizontal. So draw the horizontal, then we're going to draw the 2 Newton force here. So 2 Newton force, and based on the scale, that will be 10.0 cm. Then we'll draw the 1.3 newtons, and based on the scale will be 6.5 cm. From here we will draw a parallelogram, and from here we will draw the resultant force. And the resultant force is represented by a double arrow. Taking measurements, we can find that this resultant force has a length of 12.8 cm, giving 2.56 newtons. So we will state that the resultant force is 2.56 newton, and the direction is 90 degrees to the horizontal. Now, do not use north, south, east, and west over here. The question did not say where is north, so you should not use north in your answer. Alright, and part B, hence state the weight of the stone. Here, the stone is stationary, so based on Newton's first law, the total upward force equals to the total downward force. So the weight will be equals to the resultant force, and that will be 2.56 newtons. Question 3 is on work energy power. So a steel ball of mass 5.0 kg was dropped onto a tray of sand. The steel ball hits the sand with a speed of 12.0 meters per second. Now, I always recommend students to draw or sketch out a diagram. So here we have a ball that's falling, and it hits the tray of sand, and we are supposed to find the kinetic energy of the steel ball just before it hits the sand. So here the speed of the ball is 12.0 meters per second, and we know Ke is given by half mv square. Now, in your answer, I strongly recommend you to state the formula for Ke. Now, the symbol for Ke is Ek. Okay, try not to use Ke. If not, you spell it out. Kinetic energy equals to half mv square, and put in your values of half, and the mass is 5.0 kg, and the speed is 12.0 meters per second. Remember the square, and you will get your answer of 360 joule. Calculate the height in part B from which the steel ball was dropped. Again, in your diagram, the ball was dropped from a height h. And what is that height? Again, write down the values of the speed and what energies are available. So here you know that the speed is 0 meters per second at the top, and the formula for GPE is mgh. So in terms of physics concept, the loss in GPE will be the gain in KE. So mgh equals to half mv square, and substituting the values in, you will get height of 7.2 meters. Alright, in part C was a question that many students have difficulty answering. So the steel ball was embedded 0.040 meters into the sand. Calculate the average stopping force of the sand. So here, drawing a quick diagram, the ball hits the tray of sand and moves into the sand. And there is a braking force due to the sand. And what happens is that this kinetic energy of that you have found earlier which is the 3600 joule of energy, that energy is lost, and that causes the ball to move 0.040 meters into the sand. So in terms of the physics, the work done against the stopping force will be the loss in kinetic energy of the ball. So force times distance equals to loss in KE, and force times 0.040 meters will be 360 joule, and you will get your answer of force as 9,000 newtons. Question 4 is a question on mass and weight and moments. So there's a helicopter that is stationary in the air. The weight of the helicopter is 150 kilonewtons. Describe the difference between mass and weight. So there are many differences, but you need to state differences that really shows the difference between mass and weight. So mass is the amount of substance in an object, and weight is the gravitational force on an object. Or you can say mass is independent of gravitational field strength, while weight is dependent on gravitational field strength. Now, I do not recommend, it is really not recommended for you to use the differences as scalar and vector, whether it's a beam balance or spring balance, because these do not adequately distinguish between mass and weight. So what's the mass of the helicopter in part B? So the formula for weight is W equals to mg. Now W is given as 150 kilonewton, which is really 150,000 newtons. So from here, you will get a mass of 15000 kg. Continuing with question 4, state the principle of moments. For an object at equilibrium, the sum of clockwise moments about a pivot is equal to the sum of anti-clockwise moments about the same pivot. Now, it is important for you to state the principal moments in its entirety. You need to state it completely. In C part 2, by taking moments about point X, calculate the lift force from the front rotor. So when we take moments about point X, we are actually saying that the pivot is at point X. And from that, we can find the clockwise moments and anti-clockwise moments. So let's start off with the weight. The weights downwards will produce an anti-clockwise moment. And from here, we can find the perpendicular distance of 5 meters, followed by the lift force from the front rotor, which will produce a clockwise moment, and it will give a perpendicular distance of 12 meters. So using the principle of moments, sum of clockwise moments equals to sum of anti-clockwise moments, we can find F times 12 meters equals to 150 kilonewtons times 5 meters, and that will give a force of 62.5 kilonewtons. Question 5 is on waves. So figure 5.1 represents a snapshot of a wave at time equals to 0 seconds, and the wave is moving towards the right. State the amplitude of the wave. So amplitude, as you recall, refers to the maximum displacement from the equilibrium position. So this is the equilibrium position, that's the maximum displacement, and so this distance here will be the amplitude, and that will give you 20 cm. In part B, draw and label the length of one wavelength away from point P. So one wavelength refers to the distance of a complete wave, and the question specifically says one wavelength away from point P. So you need to start from point P and move one wavelength. And you need to label. You are required to draw and label. So please label one wavelength. Now, in this question, the wave is moving towards the right side. So in this question, where would point P move in the very next instant? So point P will move downwards, so you need to draw a downward arrow. And if you want, you can say P moves downwards. But P, you have to draw the arrow on point P. Okay, so how do you know P is moving downwards? There are two ways you can do it. You can draw the next wave, or you can look behind the wave. So behind the wave means this part of the wave is moving downwards, and so P will move downwards. Explain why the waveform in figure 5.1 is a transverse wave, and that's because the particles in the wave are moving perpendicular to the direction of wave motion. You can say that it moves perpendicular, it oscillates perpendicularly, vibrates perpendicularly. They are all accepted. So point P in part E, it returns to the same position after 0.02 seconds. So this tells you that the period of the wave is 0.020 seconds. And using the frequency equals to 1 over T formula, that will give your answer as 50 Hertz. With reference to 5.1, calculate the speed of the wave. So using the wavelength that we have determined earlier, this wavelength is 40 cm, and using the wave speed equation, v equals to f lambda, 50 Hertz, 40 cm will give us 2000 cm per second, or if you want to convert, it will be 20 meters per second. Question 6 is on the topic of refraction and test your understanding of the concepts related to refraction. So figure 6.1 shows a light ray PQRS as it enters and leaves a glass block. Figure 6.1 is drawn to scale. Explain why there is no change in the direction of the light ray as it enters the block at Q. So we are looking at this part of the diagram, and why is there no change in the direction of light is because the angle of incidence at the point of incidence Q equals to 0 degrees. Or you can say the light ray PQ is parallel to the normal at the point of incidence Q. Now it is important for you to state that the point of incidence at Q, alright, so that we know which angle of incidence you are talking about. Now some students wrote because there is no change because the refractive index doesn't change, which means the refractive index outside the glass is the same as inside the glass. Now this doesn't make any sense because the light ray does change when it comes from R to S. So there is a change in optical medium. So in part B, explain why there is a change in the light direction of the light ray as it leaves the block at Q at R. So we're looking at point R. So the light ray is traveling from an optically denser medium to the optically less dense medium. And the angle of incidence is bigger than 0 but smaller than critical angle, and therefore the speed of light increases, and therefore refraction occurs with the light ray bending away from the normal. Now most students were able to tell in their answer that the light ray is moving from optically denser medium to less dense, but some students left out the word optical. You need to mention it is an optical denser or optically less dense medium. Most students left out this, which is very important. If the angle of incidence is 0, then the light ray will pass straight through without a change in angle. If the light ray has an angle bigger than critical angle, then what happens is that this light ray will have total internal reflection. So you must be very clear in your answer that the angle of incidence of R is bigger than 0 but less than critical angle. Alright, and therefore the speed of light increases and the light ray refracts and bends away from the normal. Question 6 continues with asking you to take appropriate measurements and to determine the refractive index of the glass block. So to do that, you need to first determine the angle of incidence in the glass, and the angle of incidence is given by the incident ray and the normal. So this will be the angle of incidence, followed by the angle of refraction in the air. So again, the refracted ray, the normal, and then this angle of refraction. Then you will use the refractive index N equals to sine I, which is in air, over sine R, which is always in the medium. So giving you sine 60 over sine 35, that will give you 1.51 to 3 SF. Now, many students measured the angles wrongly. The very common one is that students measure this angle or this angle instead, and those are not correct. Angles are always measured to the normal, and you need to bring your protractor for your exams. The refractive index in part D of diamond is 2.2. Calculate the speed of light in the diamond. Now, the refractive index N is given by C over V, and you need to remember C as the speed of light in vacuum, which is 3.0 times 10 power 8 meters per second. And from there, you can find V as 1.4 times 10 power 8 or 1.36 times 10 power 8. Both answers are accepted. Question 7 is on electromagnetic spectrum. So here you are given 4 electromagnetic spectrum: X-rays, microwaves, UV, and infrared rays. And you have to place them in increasing wavelengths. So going from the shortest wavelength to the longest wavelength, which means we are going from the higher frequency to the lower frequency. So of these 4 wavelengths, X-ray will have the highest wave frequency, and followed by UV, infrared, and microwave. So in part B, state 2 properties of that these 4 different types of radiation have in common. So there are many properties you can state. They can transfer energy without transferring medium. They undergo reflection, refraction. They travel at the speed of light in vacuum. They do not need a medium. They are all transverse wave, and they do not have electrical charges on them. Now, this question in part C asks how is one of those 4 different types of radiation used for communication purposes. So the emphasis is really how one of these 4 different types, and is being used for communication. And of these 4, only microwaves are used, and in this example, it will be used for mobile phones and satellite communication. Question 8 is on mass weight density. So first part, explain or state what is meant by the density of iron as 7.87 gram per cm cube. So it really means that the mass of 1 cm cube of iron is 7.87 gram. Now, some of the students, you went to define what is density. You stated density is mass over volume. Now, that is not accepted here because the question asks specifically what is meant by the density as 7.87 gram per cm cube. So you need to make reference to the numbers 7.87 grams per cm cube. In part B, determine the mass of each block. Density is given by mass over volume, and therefore mass is density times volume. And from here you can calculate the mass of aluminum, copper and iron. And in your data table you should not include the units gram, because the units of gram is already stated in the header. So part C, state with a reason which metal block has the greatest inertia, and that will be copper. Copper has the largest mass and therefore the greatest inertia. Continuing with question 8D part 1, label each block with a different type of metal such that the stacked block is the most stable. As most of you answer correctly, you should put the largest mass nearer to the table. So in this case, the largest mass, which is copper, should be placed right at the bottom, and the lightest mass, which is aluminum, should be placed right at the top. Now, how would you explain this? Most of you were able to answer that placing the heaviest block nearer to the table will lower the center of gravity, and that is correct. But most of you did not continue with your explanation and did not answer the question completely. You have to say that this stack block can be tilted to a larger angle of rotation before the line of action of the weight through the CG exceeds the base area. And these two reasons are why lower CG is more stable. Alright, so it is important for you to answer completely and to state that the stack blocks can be tilted to a larger angle of rotation. In question 8 part E, you are asked to find the density of the combined block of metal. So the density of a combined block is really just the total mass over the total volume. Now you have to be very careful in the conversion of your units. So 1 meter cube really is 1 meter times 1 meter times 1 meter, and that will be 100 cm times 100 cm times 100 cm, and that will give 1 million cm cube. So 2400 cm cube is really 0.024 meter cube. Many students made this error and converted 24,000 cm cube to 240 meter cube, and that is not correct. Mass 1 kg is 1000 grams, and so 156240 grams is really 156.240 kilogram. So the density of the mixture is total mass over total volume, and that will give you 6510 kilogram per meter cube. Now you can also convert your answer. You can also calculate your answer based on gram per cm cube and then convert it to kilogram per meter cube. And the conversion is 1 gram per cm cube is 1000 kilogram per meter cube. Question 9, test your understanding of the converging lens, the light rays, and object and image. And in question 9a, you are given an object, you're given an image. You're supposed to find the location of the lens. To do that, you need to draw a light ray from the object to the image. So we'll start off from the tip of the object, drawing to the tip of the image. And here you will find that this light ray intersects with the principal axis at this point, and that will be the location of the lens. So draw and label the lens. You need to draw the lens with a double arrow and label it lens. To find the principal focus of the lens, you need to draw another light ray. So this light ray will be parallel and then moving to the image. So then you can find the principal focus. Again, label it with the alphabet F. To find the focal length is given by the distance from the center of the lens to the principal focus, and so it will be this distance, and when you measure it, it will be about 3.2 cm. Okay. Now you can also draw another light ray from the image towards the object. That will also give you the F and also can give you the focal length. Both answers are okay. They are accepted. Question 9b continues with the object being moved further away from the lens until the object is very far from the lens. So at this current position, the object is between 1f and 2f, and the image is more than 2f away, and the image is magnified. When the object is moved further away, now if you imagine that this object is now at 2f, the image will also be at 2f and it will be of the same size. As we continue to move the object further away, greater than 2f, the image moves even nearer to the lens. It is now between 1f and 2f, but it has become diminished in size. When the object is at infinity, the image is exactly at 1f and it is diminished. So to answer the question, what happens to the position of the image? The image moves towards the principal focus until the image is exactly at the principal focus. And what happens to the characteristics of the image? The magnification of the image will decrease, or the image becomes smaller or become diminished. In question 9c, you are given a piece of glass with a refractive index of 1.6, and you are supposed to calculate the critical angle of this glass. So sine c equals to 1 over n, and that will give you a value of critical angle of 38.7 degrees or 39 degrees. Either answer is accepted. Then you are asked to draw the path of the light ray as it reaches y and emerges into the air. So at point y, you need to find out where is the normal. So draw the normal at point y, at the point of incidence, and you will calculate the angle, the incident angle of 45 degrees. And this 45 degrees is greater than the critical angle. So total internal reflection will occur, and the light rays reflects with 45 degrees and going into the other side of the glass and emerges into the glass, into the air with no deflection. Alright, so this is the light ray that you need to draw. You need to put in the direction of the light ray for your answer. So in part C, explain why the light ray travels in this path. So at point Y, the angle of incidence is greater than the critical angle, and light ray is traveling from an optically denser medium to an optically less dense medium. So total internal reflection occurs, and at the other point, the angle of incidence is 0, hence there is no change in the direction of the light as light emerges into the air.